We're going to do a quick review of graphing and exploring quadratic equations. So I'm not going to be doing every problem that you end up seeing on the video, but I will do a few pertaining to the topics that we've covered so far. So again, graphing quadratic equations. A quadratic equation takes the shape of a parabola, so a U shape. If my leading term is positive, it's going to open up like a U. If my leading term is negative, that means it's going to open down like an N. Now, for this first problem, we're going to graph the following equation, 3x squared plus 6x minus 4. So as long as we're just graphing it, we don't need to do anything fancy like finding the axis of symmetry, determining the vertex algebraically. We can just plug it into the calculator where it's y equals, and we just plug in our equation 3x squared plus 6x minus 4. And we can take a look at the graph so we can see what it looks like. So it is a U shape opening up because our leading term is positive. And what I want to do is I want to go to the points and find the area where my y values are repeating. So here we see -4s are repeating, so I got to go down a little bit. And this means from the values of x equaling -4 to 2, that is where my y values repeat. Now, obviously, we can't fit a y value of 20 onto our graph, so we're only going to deal with the ones that can fit on our graph. So the first one I'm going to do is that -3, 5. So -3, 5 is going to be the first one that I plot here. So back 3, up 1, 2, 3, 4, 5. And we have -2, -4, so left 2, down 4. -1, 7, so left 1 from our origin, down 7. And then we start repeating back up. So 0, -4, so origin, we go down 4 spots. And 1, 5, so right 1, up 5. So here we can see it's a rather narrow one. And again, we just want to graph the U as best as we can, as close as we can. So draw our U shape running through the lines as best as we can. So there is the graph, and again, make sure we have arrows at the end to show that we go up and left and right forever and ever to infinity. So the axis of symmetry, that is the x value around which I repeat. So if we look at the calculator, it's the x value that's smack dab in the middle, which is, in our case, -1. So the axis of symmetry is x equals -1. And the vertex is the x value of our axis of symmetry, so -1. And when it was -1, we got a y value of -7. So there's my vertex, -1, -7. Domain is the list of x values going from left to right, just like reading a book. So these arrows, despite it being a very narrow parabola, again, we are going up and left forever and ever, and we're also going up and right forever and ever based on those arrows. So the domain, because I go left to the left infinitely, we have -infinity, and we go all the way to +infinity. Again, we use parentheses because we can't technically solidly hit infinity. The range, again, is the list of y values from bottom to top. So what is my bottommost y value? It is -7. And because I solidly hit it, I'm going to use brackets. And then I go up forever and ever. So we have infinity, and I'll close it with parentheses. Now it says find f of 1. So this is when x is 1, what is y? So we can use our graph. So here's my x value of 1. I want 1, and I say I went up 1, 2, 3, 4, 5 spots. So f of 1 is going to be 5. The other way, we could have used the calculator. When x is 1, what's my answer? It's 5. Find f of -2 is the next thing. So I go left 2, and I see I go down 1, 2, 3, 4. So -4 would be f of -2. And again, with the calculator, we could have gone to x is -2. What's my answer? My y value? -4. So that's how we can get it, either reading the graph or a calculator. Now, do I have a maximum or a minimum? So does this mean my turning point is that the lowest point or is it the highest point? So on this graph, it's the lowest point. So we have a minimum. Now we can do that with the same thing for the second problem, which I'm going to skip because it's basically the same thing. And we took a look at it yesterday as well. Now, sometimes what happens is we're given a couple functions and they ask us a question like this one, given the following two functions, which one has the larger maximum? So first thing, the larger maximum, what's my highest point on this one? So I see at my turning point, which is right there, it has a value of 1, 2, 3, 4, 5, 6. So there is that value. So now what I want to do is I want to compare this to my generic equation. So I go to y equals and I plug in negative 2x squared minus 8x plus 3. And because we're looking for the highest point, I'm going to go to look at my table. So I want to, again, find turning points so that my wraparound is complete. So here we have y's. I start at -7 and I go to -7. Now the highest point, again, is the y value that is highest. So in this case, the high value is a y value of 11. So the maximum on this one is the turning point -2, 11. So the highest point is 11. So which of the two has the larger maximum, 6 or 11? Well, last time I checked, 11 is bigger than 6. So the equation has the larger maximum. Now number 4 is very similar, except it's asking which one has the least minimum. You would do the same thing we just did in the other problem. Figure out the y values. In this case, it would be the lowest y values, and which one is the lowest of the three would be our answer. Number 5 here, the equation of the axis of symmetry of the graph of this equation is blank. So again, we can look back. You can look back at some of my other videos, but the axis of symmetry has the equation x equals negative b over 2a. So as long as it's standard order, highest exponent to lowest, which it is, the numbers go in order. So a is 2, b is -3, c would be +7. So I plug these values in. So the negative value of -3 all over 2 times 2. So change the value, -3 becomes +3. 2 times 2 is 4. So again, because it's x equals 3/4, I want number 1. Now here we have for our example 6, the roots of the equation 3x squared minus 27x equals 0 are blank and blank. So what we can do here is we'll do it algebraically, and then I'll do it quickly on the calculator to show you the two options. So algebraically, I want to make sure that I can factor this, because roots, we need solutions, values of x. So we're using some form of factoring, whether it's difference of two perfect squares or factoring a trinomial, quadratic equation, doesn't really matter. But first and foremost, the thing that we always look for, is there a common factor that I can divide off of these? Well, 3 and 27 are both divisible by 3. And then x squared into x, I can divide both of them by x. So what this means is I pulled off 3x. And then what do I have when I divide off? Well, 3 divided by 3 will cancel out. X squared divided by x is just x. And then -27 divided by 3 gives me -9. And x divided by x is just 1, so we don't really need it. So once we pull off the common factor, we end up with 3x times x minus 9. Now this, because we can't go any further, this is when I split them up and set each of these equal to 0. And again, they both have x, so both will be set equal to 0. So 3x equals 0 and x minus 9 equals 0. So on this side, we're going to divide by 3. 0 divided by 3 is just 0. And on the other side, we're going to add 9 to both sides. So we get x equals 9. So we're looking for 0 and 9, which happens to be number 1. Now with the calculator, we could have gone to y equals, plugged in 3x squared minus 27x, gone to our table, and look for the x values that give me an answer of 0. So 0 gives me 0, hence x equals 0. And then I look for the other 0. So start wrapping around, and I see 9 gives me 0. So x equals 0, x equals 9. Those are my answers. And then number 7 is just reading the graph. What's the vertex and axis of symmetry? Well, vertex is the turning point, the very tip top or the very bottom of it. In this case, we have a maximum. So maximum is right there. So the point, I go right 1 and up 1, 2, 3, 4, 5, 6. So the vertex is 1, 6. So 3 and 4 are gone. And then the axis of symmetry is always x equals 1. It told us the axis of symmetry is y equals 1. So because it's not, it has to be x equals, therefore it's number 2. Therefore, number 2 is our answer. Vertex at 1, 6. Axis of symmetry is x equals 1. So again, that's just reviewing, reading a graph, and solving quadratic equations for their roots.